Hello, and thanks for using TickBoom, a free service that helps high school students with their math problems. For this video, I want to take a look at the second question that we see here in this screenshot. The question says, create a geometric proof demonstrating that a minus b times a plus b is equal to a squared minus b squared. So naturally, if you were to just expand those brackets, you'd get to the result pretty easily. But here we want to see a geometric proof. So basically, what's another way that we could prove this result using some form of geometry? Now, just by way of background, this question hasn't been sent to me by a student. This is actually a question from a subject I'm doing as part of my Master of Teaching program. So the subject is called Math Curriculum 1, and it's basically working through a whole bunch of the syllabus topics that you would tackle if you were a Year 7 or Year 8 student in New South Wales. So funnily enough, a lot of these seminars that I attend, they're essentially us working through a whole bunch of interesting inquiry-based problems. My high school math is so rusty that inevitably for most of these questions I can't work out the solution, or even if I can, it really takes me quite a lot of effort. But for the first time all semester actually, I finally hit a question that I could actually work out without too much difficulty. So I thought to mark the occasion, I'd make a video of it, almost just to remind myself that actually, hey, there is something that you do remember from over 2 decades ago. So I'll have a work through this now. Hopefully you find it helpful. You probably may have already seen something like this, but if you haven't, hopefully this geometric approach to proving this result might help you understand it a bit more deeply, and possibly even help with remembering why it is the case that this result holds true. So I'll just write what we're trying to prove. So we want to prove that a minus b times a plus b would be equal to a squared minus b squared. And as I've already mentioned, you could expand these brackets and algebraically show this to be true, but we want to use geometric methods to help show this. So I think whenever you're trying to prove something involving squares, the geometry that I think will naturally apply is literally the geometry of squares. So what I'll do is I might just draw up a square. So I'll just actually make sure I draw this as a proper square. So that's about 6. Okay, so here we have a square. All the sides are of equal length, and I'll call this square, I'll give it a length of a. So each of these sides will be a, and we know that the area of this square would be a squared, which is where this comes in. Now what I might do, maybe I'll use a different color, is I'll draw a smaller square inside this bigger square. So we'll have this square here, and we'll give this square a length of, we can call this b. So each of the sides of this square will be b. And so naturally the area of this square here will be b squared. Now if we want to take the difference of a squared minus b squared, the difference of the area of the big blue square minus the area of the red square, what we'd be left with is what I'm shading here in black. So this area that's left over, that's the difference between those two squares. And we can visually kind of break this down to be essentially 2 rectangles. So this first rectangle, this side will have a length of a, and this side here of the rectangle will be, the length will be a minus b. because it's the total length of the side less the length of this side of the squared b. So here we've got a rectangle of dimensions a and a minus b. For this rectangle here, we know its height is b, and the width here similarly is the total length minus b, so a minus b. So essentially what we can say is that this area of the big square, which we know is a squared, minus the area of this smaller square, which we know is b squared, that's essentially going to be, if I call these two rectangles rectangle 1 and rectangle 2, we can say that the a squared minus b squared will be the area of rectangle 1 plus the area of rectangle 2, because visually we see that this total area shaded here in black is the difference of the two squares. So again, using the formula for the area of a rectangle, we'd get a times a minus b, so this length times this length. And then for rectangle 2, we'd get b, being this side, times a minus b. And then we can factor this a minus b, so we get a minus b, and then what we get is we get our a, and then we get plus our b. And that's the result. Boom! So you can see taking a geometric approach to this question leads to a very simple proof, not a lot of argument required, just a few lines of logic there. And it all comes down to just noting or kicking things off by saying if we're dealing with something squared algebraically, we can convert that to a geometric concept by actually drawing up squares. So hopefully that makes sense, and perhaps it's a technique you could apply in other geometric proofs that you may face. If you found that explanation helpful, please be sure to give it a like. And if you're someone who wants to keep their finger on the pulse with the kinds of questions that other students are struggling with, please be sure to subscribe to my channel so that you can stay in the loop. Alright, tick boom.